This is question number 8 from the 5.5 homework. We are asked to simplify this. There are two ways to work this. The first way, what they hope that you will recognize, is that you have exactly the same thing here as you have here. And since you have the same thing here and the same thing here, with opposite signs in the middle, even though this is pretty complicated, it is going to be a difference of squares, which means you take the first part, which is your A, and square it, and then you take your second part, which is your B, and you square it. So this would work as 3h minus k squared, that's your first part squared, minus your second part squared, which would be j squared. And then they want you to multiply this out, and it is a perfect square trinomial, which has this pattern. And the way we talk ourselves through it is you square your first term, which means you square both pieces, so that's going to be 9h squared. You use the sign from the middle. You multiply these two things together, which would be 3hk. You don't have to worry about the sign because it's already taken care of. And then you double it to get times 2, which is 6hk. So this is going to be minus 6hk, and then it's always plus the last term squared. So plus k squared, and then you have the minus j squared. That's the way they hope that you recognize to do it, but it is not the only way to get it done. I've rewritten the problem here. And instead of seeing it as where we have parentheses inside where these are grouped together so that hopefully you see that they are the same, you can also just think of this as two trinomials that you are multiplying together. The parentheses are only here so that you can see that they're the same, to make it look like a group. But mathematically, they don't make a difference. Okay? Now think of this as a distribution. I'm going to take this 3h and distribute it all the way through here. And then I'm going to come back and do the k, and then I'm going to do the j, and we'll combine like terms. I'm going to try to keep my like terms lined up so that they're easy to combine. 3h times 3h will be 9h squared. 3h times a negative k is going to be minus 3hk. And then I have 3h times a negative j, so that's minus 3hj. So I've distributed the 3h through this whole thing. Now I'm going to do the negative k. Negative k times 3h is going to be negative 3hk. I'm just lining up my like terms to make it easy. Negative k times negative k is going to be a positive k squared. I put it over here because there's nothing up here to line it up with. And then negative k times negative j is going to be plus kj. I don't have this term in there, and I don't have this term. That's okay. I have nothing here and here. I'm just lining things up. Now distribute the j. J times 3h will be 3hj. Lining it up with that one. J times the negative k is going to be minus kj, and then j times j that's going to be a negative j squared. Okay, so I'm going to add all these together, and it might look a little bit complicated right now. What I'm going to do is I'm going to go put in some zeros where I don't have things to add, just so you can see it a little bit better. Okay, now add these up. I have 9h squared. This is going to be minus 6hk, minus 3hj plus 3hj, that cancels out. I have a plus k squared. The kj's cancel, and I have minus j squared. Okay, so I've got exactly the same answer as here. It's workable without recognizing that it's a special form, but it is somewhat easier if you do recognize that.